Hey, my name is David Poggen, and I'm here to explain a few things about this circuit today. This circuit is ran out of 14-2 gauge wire because it is a 15 amp breaker. It's protected by both AFCI and GFCI protection. AFCI means arc fault circuit interrupter, and GFCI means ground fault circuit interrupter. The AFCI actually monitors the waveform of the current, and if at some point there is a arc that is not operational, it will trip and cut off all power to the circuit. The GFCI it monitors the incoming current in the line side and the load side as well. And if the two current 2 ampacities are different, then it will actually trip the breaker and cut off everything on the load side. The line side will still have power, but everything after that will be off. AFCI was made to protect from fires, and GFCI is to protect people in case of them touching the hot or a hot box or something. The next thing would be a three-way switch. Three-way switch has the hot coming in one side and then the leg coming out of the other, which is to the light. In the yellow right here, I have the neutrals highlighted. The neutral is just tied all the way through to the light. The hot goes to one terminal, the common terminal on one three-way switch, which would be a black terminal. And then the 2 brass terminals are used for the travelers, which you see in green right here. The travelers then go to the other three-way switch on the same terminals, brass terminals, and then on the black or common screw, the leg comes out to supply power to the light. And whenever you hit the switch, it switches the current from one of the travelers to the other, and it will allow current to pass to the light only when one of the 2 path plays is completed. The last thing I'm going to talk about is the combo switch. The neutral, as with most things, the neutral is tied all the way through to the light or fan, and then there are 2 separate legs or wires to go to the light or fan. One will supply the light kit and the other will supply the fan. And then on the other side, there is a hot coming in which supplies both switches with current, or it can be broken. There's a tab in between that can be broken to allow for multiple circuits or multiple circuits on one switch. That's about it.
All right, my name is Cody Stewart, and I'll be talking about AFCIs, doorbell, and a three-way switch. So an AFCI, according to the NEC, is a device that protects the circuit from any type of arcing and can recognize any form of arcing. You are required to have it in either bedrooms, any place that other than kitchens, stuff like that. And you're required to have one for 15 to 20 amp circuits. Next thing I'm going to talk about is the doorbell. So the way the doorbell works is right here you have your incoming power that goes straight to the transformer. The transformer is a step down because there are more windings on the primary than the secondary, so it's a step down transformer. So the incoming would be 120 volts, and then the outgoing is 16 volts. Whenever you press one of the doorbells, it will energize one of the coils inside of there, creating an electromagnetic field to pull down one of the plungers to cause it to ring. Next thing I'm going to talk about is your three-way switch. So the way the three-way switch is you have your incoming power, and then from the incoming goes to the travelers on the three-way. From the travelers goes all the way to the other three-way switch, And then from this three-way switch, you'll have the wire going to the light. So the way this works is whenever you flip one switch off, it'll break the circuit basically, because there are two little things in here that will either complete the circuit or break the circuit to light up the light. And that's it.
My name is Nick Whitaker, and today I'll be talking about 3 different types of devices we have in the circuit, and that is a small appliance branch circuit, the GFCI, and the stack switch. The first one we'll start out with, since it's the first in the line of the circuit, is the GFCI switch. It protects anything downstream from it. It protects humans and animals, or any type of life that decides that it wants to touch something, and say it's got a faulty box or a faulty device, that it will not shock or hurt anything that it hits. And if water gets to a different plug downstream from it, it will knock all the electricity from the system, so it will not short anything out or deliver a shock to faulty equipment. Next thing I'll be talking about is a small appliance branch circuit. It's at least 2 required in a circuit and 20 amp base. It's used mainly for kitchens and bathrooms and laundry rooms. You usually hook your stove, refrigerator's optional, or anything that draws a lot of current and power to it. The last thing is the stack switch. Stack switch is also called a duplex switch and can be used as either a single pole or a triple pole. You can use it to control lights from different sides of the room, or you can turn it into a single pole by clipping a metal tab in the middle of it, and it can be used as on the fan here when one turns the light on and off, and one turns the fan on and off. And that's it.
So today we're going to be doing 3 devices that we used on our projects, and one of them was a smoke detector right here. And there are 2 types of smoke detectors, the ionized and the photoelectric. And for this one we use the photoelectric, and the photoelectric has a beam of light that shoots across the chamber, and whenever smoke particles go through the chamber, it redirects the light to the sensor, and that would cause the alarm to go off. And smoke detectors shall be installed in all sleeping rooms, also in new constructions in every floor, and they also have to be AC powered. And another thing that we used was a GFCI right here. Here's a little diagram of how it works. And for a GFCI, it's built in with the outlet, which is right here. And that's our GFCI right there. All right, so, and the GFCIs are required in bathrooms, in kitchens, anywhere where it's near something with water. And the NEC also states that for every GFCI, it should be 125 volt single phase, and it could be 15 to 20 amps. And then let's see, we also have our 3-way switch, which is, here's our little diagram right here. So on each side we have our travelers, we have our neutrals, and our hots right here. And then the 3-way switch is a switch that creates a complete circuit for a current to flow through the bulb. And this switch can be used to control the light from either side of the room. So you could turn it off there and then turn it on there. And yeah, that's it.
We're gonna talk about single pole, light fan, and AFCI. The AFCI detects any overload, shortage, or arc, and as soon as it detects it, it'll completely go off. It'll reset the whole thing. And next, we're gonna talk about the single pole. The single pole is connected. We put it connected to the GFCI, so any simple lights, anything, you control that. And then the fan light, which is connected to the stack switch, we put it connected right there, and it can control both at the same time or anything. For example, that one right there is control the fan, turn that off, or turn the light on, or you can turn both on or both off. That one right there takes about 1.5 amps when we measured it, so it's about 196 watts. And yeah, that's pretty much it.
I'm going to be talking about the ground fault circuit interrupter, the GFCI, the three-way switch and the traveler wires, and then finally the doorbell. The GFCI is the first thing that is running through to our power. Its main purpose is to protect against human shock. It can detect a change in current of up to 0.005 amps, and then it shuts the circuit down. It's required in places like anywhere that water's around, so it has to be in kitchens and bathrooms. It's required on all small appliance branch circuits. Okay, the traveler wire is the red wire that leads from the two three-way switches. And its purpose is to provide a second pathway of electricity to the two three-way switches. It makes it to where either one of the three-way switches can close and open the circuit. Three-way switches are usually single pole double throw switches. Let's see. They're wired with a 14-3 wire from the two switches have 14-3 wire going to them, and then from the light fixture it is a 14-2 wire. And then the doorbell, basically whenever power gets to the doorbell, the circuit is closed and it energizes an electromagnet, which generates a magnetic field. The magnetic field will work a mechanism which will pretty much sound the doorbell.
And I'm going to be talking about transformers, smoke alarms, and AFCIs. And with transformers, this one in particular is a step-down transformer, meaning that the high voltage coming in here is going to lower it for the doorbell down here. And it does this because it has an iron core in it, and the coils are wrapped around this core, which it'll have less coils coming out of the secondary side and more out of the first side. And vice versa, can also be a step-up transformer. So it'll have more coils and less coils on either side, depending. And then for smoke alarms, there's two types: ionization smoke alarms and photoelectric smoke alarms. And the way those work is they have a chamber where the ionization smoke alarms have two plates with electrical current running through them, and it ionizes the air between. So when smoke gets in the chamber, it disrupts it, setting off the smoke alarm. And same principle with the photoelectric smoke alarm, because the smoke will disrupt the light sensor going through that chamber. And then we also have a AFCI breaker here, which stands for Arc Fault Circuit Interrupter, which is an electrical protection device meant to stop fires and overloading the circuit, because it'll trip if it detects an arc fault, which usually happens at faulty connections. And it'll also detect when too much current is flowing through the circuit, and it'll trip and shut off the circuit.
My name is Jeff Brennan, and this is our residential wiring project. So I'm going to start with the doorbell, which means we have to start with the transformer right here. So we've got 120 volts coming in to the transformer, but that's way too much for this doorbell to handle. So what we need to do is we need to step down that power, and that's where the transformer comes in. Using electromagnetic inductance, it's going to convert 120 volts down to 16 volts. Now, the way that's accomplished is that on the primary side, there's more windings than on the secondary side. When one magnetic field meets the other on the secondary side, that steps down the power to 16 volts. After that, we wire the transformer to the doorbell, and whenever one of these buttons is pressed, that's going to complete the circuit, and release the solenoid so the chime goes down and hits the hammer. Moving on to the smoke detector up here. Now there's two main types of smoke detectors. There's photoelectric and there's ionization. This is an ionization smoke detector, and it works better with fires that are more kind of flash fires rather than a smoldering fire. The principle behind it is pretty simple. There's an ionization chamber inside here, which we can't see because the cover's on, but there's a source that's emanating these things called alpha particles. Now, between two metal plates in the ionization chamber, there's a constantly running current, but when there's electrons going from positive to negative, that current gets interrupted when smoke binds with an alpha particle in the ionization chamber. When that happens, the current is weakened or cut off, and that's when we get to hear this lovely noise. Great, huh? You'll also notice that there's this red wire that's disconnected from anything. That's called a traveler. Now, in a normal home, that traveler would be connected to another smoke detector, and all the smoke detectors would be connected together by travelers. We also see travelers in our three-way switch. Now, I don't know if you can see that, but the three-way switch operates on a very simple principle. Basically, it powers a light, or mainly lights. Let's say if you have two entrances or exits in a room, you would have a switch near both doors, so you don't have to walk across the room in the dark. The principle is very simple. It uses that same idea of the traveler from the smoke detector to go between the switches, which ensures that there's always current available to the light depending on the state of the switches, if they're on or if they're off. In this case, we're looking at this light. So both of these are in the off position. We pretend this is in the off position. We flip that, and that's going to activate the light. We can also deactivate it from the switch, and that's all due to the travelers. And that's going to be it for me. Thanks a lot.
I'm Charles McDaniel. This is my capstone project for ELC 113 class. Welcome. I'd like to take just a moment and demonstrate my project for residential wiring. This is a schematic layout. If a contractor were to see the installation we have today, the demonstration, this would give an idea of where the circuits and switches would be installed. Today we're using a power source of 240 and 120. We're only using 120 for today's installation. The conductors we used were 14.2 Romex and 14.3 Romex. We have a can light above, a fan with a light as well, smoke detector, our main power source. We have a nail up 3-gang box. We have a 2-gang nail up box. We have our panel board, our GFCI. We have a single switch with a single nail up, and we will do a quick demonstration and show how everything works. As well, we have a doorbell circuit over here too, with a front door and back door different chime to tell you which door is the doorbell's activated. We will show the step down transformer and power coming in as well. Okay, so right now we have 3 switches in this 3-gang box. Each one controls a different device. The first one is our fan light. The second one is our fan itself. The third one is the canister light on this particular installation. On this installation, we have, for the motion detector above here with 1 switch to activate it, we have installed here 2 3-way switches, and 2 3-way switches are used in many residential applications for, say, a living room where you would come in and there would be 2 different doors. And on those 2 different doors, you have to have access to the light to operate the same light. So that's why we use a 3-way switch. And here we would operate the incandescent light on this switch, and over here we'll turn it off. And it works vice versa, either way. Over here, We have our doorbell circuit, like I say, with 120 coming in, stepping down to the step-down transformer for 16 volts. We have the front door chime, and we have the rear door chime. As you can see, it's just a single chime. All right, I'm going to hit on two topics as well for the AFCI circuit breaker and the GFCI circuit breaker. The arc fault circuit interrupter was tested in the early 1990s. Arc faults are caused by high current arcing. The United States had 30,000 fires occurred in residential dwellings because of high arcs. So in 2008, the National Electric Code implemented a code change saying shall be. All new installations shall require an AFCI circuit breaker installation. The arc fault detects arcing through frequency. Any level of frequency changed trips this breaker. It helps to eliminate fires. The inventor of the arc fault circuit interrupter was Mike Holt Enterprises and staff. Down below here, we have the ground fault circuit interrupter. This was invented in 1961. Device normally operates until 5 milliamps passes through and causes it to go to the circuit to go to ground. Usually, an extension cord has a fray in it, touches something together, will cut this breaker off right where it is. Again, is used to help prevent fires. The ground fault circuit interrupter protection for personal or similar protection has been in a National Electric Code since 1962. GFCI receptacles are required in residential dwellings, in the kitchens, bathrooms, attics, basements, and garages. The inventor was Charles Dalzell in 1961. And I'm Charles McDaniel, and that will conclude mine.
Hey, my name is Jose Tellez, and this is residential wiring, and this is my project. I'm going to be talking about GFCI's, motion sensor, and small appliance branch circuit. GFCI, which is this protector, when current is running through it, it has to keep a certain balance. If that current is either too much or if it's too much within 5 milliamps, it will actually cut it off, and whatever connected after that will shut everything off. GFCIs are mainly in anywhere where there's water involved. So unfinished basement, outside, bathrooms, kitchens, near a sink. Motion sensor. A motion sensor uses a PIR motion sensor, which is a passive infrared radiation sensor. It has an electronic eye inside of this, which is what actually senses what's going to trigger it. And the way it triggers it, it has a transistor. There's a transistor inside the sensor. Whenever any heat, radiation, movement is within the eye view of this sensor, it'll cause the transistor to send a signal, which completes the circuits inside of it that actually cuts on the lights. It also has a photocell. Whenever daytime day starts coming up, it'll actually automatically cut it off, so during the daytime it won't cut back on. Small branch circuits. Small branch circuit is a circuit that supplies electric energy to one or more outlets to which appliances are to be connected. Whatever is in this circuit, they are not to have any permanently connected light fixtures or any part of appliance. By NAC 210-111C1 requires two 20 amp small branch circuits, one for the refrigerator. Small branch circuits feeding receptacles in kitchens, pantries, breakfast, dining rooms, and similar areas should not have any other outlets.
So today I'm going to talk about three-way switches, smoke detectors, and arc fault circuit interrupters. A three-way switch is kind of like what you see in stairways, where bottom of the stairs you can flip one switch, turn the light on. At the top of the stairs you can switch it and turn the light off. This is the basics of how it works. You get power coming in through the switch, and there's two contacts. It either goes one way or the other, and then depending on the state of the other switch, whether it's closed or open, it'll send power to the light bulb. There's all different states. You can have them all up, you can have them all down. It's a little logic how it all works. And then for smoke detectors, actually I do have to point out, there is photoelectric and ionization. Ionization works with two plates with a radioactive element in between them that creates ionized air. Once smoke particles go in there, it disrupts the flow of current and it trips the alarm. The photoelectric has a little light and a photosensor in it. Once the smoke goes up there, it deflects the light into the photosensor and it triggers the alarm. And now I have the AFCI, which is over here. It reads the current, or not the current, the frequency of a short or something. It could be the line to the load, the line to the neutral, anything really that creates a different frequency, and it'll actually trip the breaker. And that's it.